All right, guys, you're being recorded.
What?
You're being recorded. Go ahead and pass around the sign-in sheet. Everyone, make sure to get signed in. I do keep track of the sign-ins, and that's part of your ability to pass.
You have to keep it.
Yeah.
So if we just showed up, we pretty much pass.
No. I'm not that kind of teacher. You fill out your name and get some points and that. Although I gotta say, you guys have done really good on the quizzes.
Do we ever get them back so we can study for our
No,
final?
you don't.
You just throw them
I'm not
away.
interested in that kind of thing.
Do you throw them away?
I eventually will, yeah.
Oh, you haven't?
I'll eventually shred them, actually. My security shredder.
We should recycle them.
You got, man, you wouldn't believe when you hand back exams, they instantly get scanned and put on web pages and blogs, and it's just unbelievable. I actually have had people cheat in my class based on exams I've handed back, so I was like, just forget it.
Oh, that's...
Yeah.
I never even thought of doing that.
Doing what?
Taking a test and just like studying that test so that like.
Well, students sell them to each other, and you wouldn't believe the stuff that
But you
happens.
don't. The teacher could totally do something else different, and you'll never.
Well,
That's what I would do, host.
it's the hope of an easy win. Sometimes something.
I'll lie to my students. Yeah, we're gonna do this in the test, and then.
Well, that teaches good moral value.
Yeah.
Come on.
All
right.
Do not go to Miss Taylor's class.
So last week we quickly talked about human versus machine code. We talked about compilers and interpreters. What is Python? Is it a compiler or an interpreter?
It's an interpreter.
Why?
Because it puts the machine code into things we can understand. Yeah.
Yeah. So normally, like if you program in C, before you can use the program, you have to tell the machine or the compiler on the machine to compile it from human readable code into machine code. An interpreter is a program that just sits there waiting for you to feed it instructions, and it's converting it to machine code on the fly. So typically interpreters are a little slower, but they're really nice because you can just write a program and boom, it just runs instantly as opposed to compiling. Compiling can take an hour or more with some programs. The computer, the compiler actually goes over your code several times and makes it more and more efficient before it writes the final machine code. So those are called passes. It makes multiple passes. So compiling can take a long time. So people like interpreters because, man, you can write some really fast programs and change them real fast, fix stuff real fast. You don't have to worry about compiling and all this other stuff. But it is a little bit slower. So just something to keep in mind.
So interpreters are slower or faster?
It's a little slower because they're converting what's called byte code, which is a type of machine code, on the fly. So not on the fly, as you type it. Right now, all we've been using is Python, the Python interpreter. Today, we're going to start shifting gears out of the Python interpreter, actually to writing a file, writing a program, a bit of Python code in a file, saving that, and then telling Python to load it and run it. So we're going to be shifting gears a little bit today. We've done all this stuff, talked about Python. Remember we did division. This shows us dividing two integers. 5 divided by 2 with integers is what? Remember?
Are you supposed to say the answer, or what happened?
Yeah. Well, what happened when we did 5 divided by 2? We got what? 2. Because it's using integers which don't have anything after the decimal place, so it just truncates whatever the answer was. In this case, it should have been 2.5, but to get it into that mode to have data after the decimal place, you have to give it a floating point here. Remember, these are called integers. This is called a floating point. Once you introduce one floating point, it converts this one to a floating point, and then it can do floating point math, which will give you the answer 2.5. All right, and then we went over order of operations. Remember this? So, with this problem, what part of this problem does it do first? Anyone remember order of operations? Huh?
It would do the division.
Go ahead.
It would do the division.
Stuff on the right and
Yeah, it'll do the division first, then the addition. So if you want it to do the addition first, what do you need to do?
Put the addition in parentheses.
Put it in parentheses. That's standard math. That's not computer stuff. That's you're gonna do that in as you get towards algebra and stuff too. So remember this one? Ho ho ho.
I kind of messed up on that.
That's okay. So if it sees a mathematical operation here with two incompatible things, it's going to try to make it work. In this case, it's going to print ho 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 when you do that. So you can do that. I don't know why you want to do that, but I think some of you guys did like ho times 1,000 and fill the screen.
Yeah.
That's fun. Filling the screen's always fun. So there's x equals 15. So this shows us how to set a variable, and then how to use variables in math, and then how to use a print command to output this text, and then comma x plus 5, the answer to x plus 5. So here we're telling it print this text, and then comma x plus 5 prints the answer. Okay, so that shows how we can kind of format text in doing math. And then we shall show incrementing and decrementing. What's this? If x equals 16 here and we do this, what's it going to print here? This is saying take x and increment it.
Oh.
20.
Yeah, it's going to say 20. Remember, that's how we told the computer to increment a variable. And that's useful when we start getting into while loops and loops that do things. And we need to say, I think we do that next. There we go. While true, print hello world. Okay, what's this going to do here? This forms the while loop. This is the condition that it will continue doing it with. So that didn't make much sense to me. So while this is true, do this. It'll run this loop forever. So we talked about, there we go. So if we do the same thing, set y x equals 1, and then say while x is, what's the sign for? Less than. While x is less than 10, print this.
So
Well, in its current state, this will continue to run forever, right? Because x is always 1. We're not changing x. So if we wanted this thing to stop after 10 hello world prints, what would we need to do right here? If this is the condition that will make it continue to go, x is less than 10, yes. X is less than 10, yes. X is less than 10, yes. What do we need to do here to x?
make it more than 10.
Okay, how do we do that? We want to do it 10 times.
So that's star.
Make it
It's a plus, yeah.
11.
What would I type here?
X
Oh,
plus equals 10.
Well, then it'll jump to 10. So it'll print it once and then exit. If I set x equals 10 here, it'll enter this loop, print, make x 10, go back up here, check, kick out. It actually makes that noise.
Really?
No. Really. So you said x equals 10. What else can we put here to change x? We talked about it a second ago. It's okay, take your time. This is an important concept. We need to change x, but in a way that it'll do this loop 10 times.
So it's only supposed to do with x is less than 10.
Right, right.
So it can be anything.
It could, yeah. Yeah.
Is it minus equals?
Minus equals, if we
No,
do
that would make
x
it
minus
less.
equals, we'll make it 0, and then
would
negative
less
1, then negative 2.
Less than or equal to.
Yeah. So we want to do what?
Times it by 10.
Timesing it, multiplying by 10 will make it 10, and it'll kick out after once.
Oh, you need to do it 11 so that it goes 10 times
If
that.
we make it 11, that's more than 10, so it'll kick out after the first print.
9.
If we make it equal to 9, just make it equal to 9,
Oh,
it'll
then
run
it's
forever.
Just keep going and keep
Right,
going.
right.
So 1, so you
We want it to happen, loop 10 times, and then stop. X is currently 1.
X is currently 1.
Yeah.
Oh, I almost have it.
It's okay.
It's.
Aaron, any ideas?
I know how it looks, but I can't.
Let's go back.
Could you ask it to do multiple equations?
Sure.
Like maybe x plus equals 1, and then x plus equals 2, and then x plus equals 3.
You don't need to do that.
Or has to be
You
like-
do an x plus equals 1, and now it's going to be 2. Next time you loop, it's going to be 3. Next time you loop, it's going to be 4.
Yeah,
I think this
and then
has to
next
be-
time it's gonna be, it keeps getting bigger, and until it reaches 10.
That's kind of the behavior we're looking for, isn't it?
Yeah, and then
So what will we type here?
some way to write that.
It was just on the screen, dude. You missed it. How do you write it, Aaron?
Well, I did so. Let's try while x is less than 10. 10. Print. So what if I told it while x is at less than
Can
10?
you guys see this?
Yeah.
All right. Let me do a.
Print.
Okay. Hey Blake, do you want to move over here to a machine that's closer? You want to come over here? We had some other people in the other class too who were having problems seeing, so. Because this text here is going to be harder to read than the slides, so. Let me do this.
So you want it to read 10
There we go.
Do you want to stop it?
That's a better prompt.
1 to 10.
Right.
So
We're not using our computers just yet, so it's.
oh, good.
Wait, how do you get into the dot?
You have to
It's a
type
while
in
too.
Python
Or while something.
and then while.
So I want you guys just watch up here just for a second. We're not gonna, don't do it on your machine yet. So I'm gonna enter Python. That gets us to the interpreter prompt here. And I think I was gonna do x equals 1. So that sets x. Okay. I'm gonna do that while x is what?
Less than 10.
Less than 10. Do this stuff. Now I need to indent here. If I don't indent, it's not going to treat it as a part of this loop.
Is it x equals x plus 1?
Close. That's the syntax you use with C, I think. But let's try this. Print. Hello world. And I want to print like sideways, so I'm going to put a comma at the end so it'll print, keep going that way. And you said what now?
X equals x plus 1.
X equals x plus 1. Let's try that. Oh, it actually worked. 1, 2, 3, 4, 5, 6, 7, 8, 9. That was 9.
Yes!
Did I say 9 or 10? I said 10 times.
You said 10.
You get the idea. I could make x into 11 and then it would work, right? Is that 1, 2, 3, 4, 5, 6, 7, 8, 9?
So,
Yeah.
So-
and say x equals x plus.
Now, I hadn't used that syntax before. That syntax is valid in a couple different languages.
I got that from the Python cheat sheet.
Oh, did you? Well, that's okay. There you go. I wasn't aware of that syntax working.
So you don't want it to print.
Well, if I wanted to print 10 in this case, I would change 10 to 11. Because the first time it went in, it was already 1. It went in, it was 1. And it kept adding until I could say, look at this, guys. I could say this. While x is equal to or less than 10. This is another check during your Python cheat sheet. This is another check I can do that'll make it, it'll be able to go 1 higher essentially. So if I do this now,
Okay, that's
shoot.
the same game.
Check your
Does the
sheet.
sign
Is it
go with one?
that like that, right?
Well, yeah.
Yeah,
less
that's
than
it.
3.
There we go. It's confusing. If you know multiple languages, you're getting them mixed up all the time. Print.
What if you tried it with a different thing, like while x is more than 10, and then you set x as 10. What if you did that, like x as 10 minus
That would
so-and-so?
that would work. That would work. So print and then x. I'm going to do this plus equals 1 because this is the syntax we are learning in class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that worked. This is the same as what Terrence said up here. X equals x plus 1. I think this is more logical actually. X equals x plus 1 seems to make more sense to me. But this is the syntax I was teaching earlier. But all we did was, really functionally, all we changed was x less than 10 to x is less than or equal to 10. And that worked. That gave us 10 hello world instead of 9. Blake, how's your machine? Coming up? Oh wow, you got it up already. Cool, excellent. Does everyone want to go ahead and do this example?
Sure.
Go ahead and do that while I take a fun break. Should have done this before class. And now I'm on video on YouTube.
It didn't work either.
I'm not doing the same thing. His is doing.
Yeah,
Stupid.
it's not. Well, maybe we should. So I think that oh wait, I forgot the comma.
No, the comma just makes it go sideways.
You guys do it the same thing.
No.
Really? Nope, mine's 14. This is so strange. I don't know. Does the exclamation point make a difference?
Which is hello world. That exclamation point.
In putting in quotes.
Yes, I put it in quotes.
It worked for mine. If you ever have problems with that kind of thing and you're wondering, you can try the single quote instead of double quotes. Single quotes are a little more. They contain everything. They're simple.
Yeah, mine didn't work again. Oh, I know why it's not working.
Typo?
I put a space between the x and the less than equal to.
Oh yeah, don't do that.
10.
This is the comparator here, guys. The equals less than. You have to have them right next to each other, or they're not a single
I did
comparator.
that too, and I did what you did with the exclamation point in my computer. So when I do it without it works.
Well, yeah, you need to take out that space. You know what this space right here, up here?
Yeah.
Oh, I know mine doesn't have the space, but when I do the exclamation mark after hello world,
Yeah.
it doesn't work. But it works when I don't do
Yeah, mine didn't work.
Do you have quotes around it?
it. Yeah.
Do you have a comma at the end?
Yes.
Yeah.
Well,
Let me go ahead and make a trip back here. We have multiple questions. Yours first. You don't have a colon after 10. You have to have a colon after that. When you have a loop like that, guys, you have to have the last thing on the line has to be a colon.
still didn't work.
Mine's not even printing it.
Yeah, mine's not even starting to do.
Here's why. Type in X, enter.
Wait, I got it right.
X. Type in X.
Just
Oh, 11.
X. Enter. You never set X back.
Oh.
If you don't set X back to 1, then it won't work. It'll automatically kick out.
It says 11,
Yeah.
and then it's not doing anything like right here.
It's not because X is greater than 10.
Oh, so I have to set X.
X equals 1. Start over, yeah. This is kind of the bummer part about using an interpreter is you have to keep resetting everything. This is why we're going to start writing program in a file here in a minute. You got to put a colon at the end of that while loop. That defines. You ever seen a sign that says like time, place?
There we go.
Time, place, location. Like you see a sign advertising something. It says time colon, and then it tells you what time it is, and location colon, and it tells you where. Well, it's the same kind of thing here. That's telling it while colon do all this. Now hit tab. Be sure to hit tab when you go into a while loop or any type of loop. Capital W. It should not be capital W. And don't capitalize while
My things are,
print.
but when I tell it to print something, like I just tried that but with 100, it does a new line.
Yeah, that's because you have a comment. Oh yeah, if you put a comma at the end, it'll do it horizontally. If you don't, then it'll put a what's called a character return line feed in there. Go ahead and make a new line. Now, what should go there in place of question marks? Hit tab once. There you go. Now remember what we said we're going to do? We're going to increment x here. How do we increment x? How do we make x bigger by 1? You can look up in here. I've got it written in a couple different forms up there. Down towards the bottom. That'll make it instantly kick out of the while loop. You want to how do you increment? Remember how we increment by 1? How we tell x to get bigger by 1? X plus actually x plus equals. Or you don't make some more sense. Hold on. Back up. That would do it. But do this. X equals x plus 1. So right now, before you hit enter, right now you set x up here equals 1. So right now x equals 1. It's going to come through here. It's going to print. Then it's going to say x equals x, which is 1, plus 1, which equals 2. So x now equals 2. Then it's going to go through here again. Is x less than 10? Yes, it's 2. Okay, print this. Now x equals 2 plus 1. It's going to make it equal to 3. It's going to go back up here. Is 3 less than 10? Yes. It's going to do it again and again and again and again until it reaches 10. Go ahead, hit enter. Hit enter one more time to get out of the while loop. There you go. Good job.
Okay, so
Now, if you put a comma at the end of hello world, it would have gone this way instead of down. Cool. Good job.
I tried looking at the numbers to see like,
Sure.
and I did x is 20 and less than equals 30 and
Type in x, enter, see what x is. Because it's 40.
then I did x equals 20.
Okay, so 20, and then you did something here, it spit out in here, so it was 20. And then you added 20 to it,
Oh yeah.
and made it 40.
So I would need to make it like
If you wanted to do it like that, yeah. Anybody else, any questions before we move on? Did you guys get yours working? Cool. Any questions? I like this syntax better.
Yeah.
It makes more sense, doesn't it?
Yeah.
Yeah. I'm glad that you found that, Terrence. That was in the sheet I handed out.
Yep.
I didn't read. Cool. All right, guys, we're on our way to writing our first program because that's an important concept. Because when you have a program that keeps running, it keeps running because it's in a loop. Okay, so at the end of the game, it asks you, do you want to play again? If you hit yes, it's going to re-enter a loop. That's called the main, that's in most programming languages, it's called the main loop. In the gaming language we're going to be using next week, I think they just call it loop, I can't remember. But in our case, we're just going to call it the main loop. So this is how you make a loop. That's conditional based on something. In this case, the value of x. Okay, now let's check out the if. Did we do if with you guys last week? If else?
Yes.
Kind of. It's kind of the same thing, except it's not a loop. It's just a condition check. And if it's true, then do this. If it's not, then you can either do an else and then do something, or we'll see in the next slide, you can do what's called an else if, which is another, if not this, then this. If not this, then this. If not this, then you can do several checks. So let's just check a whole bunch of things at once. Does this make sense up here, right here? Don't type this in, just look. I set x equal to 15. This just says if x is less than 10, print x is less than 10. Else, in other words, if it's not